So basically, about me. In my previous life, I had a Bachelor of Mechatronics Engineering, and I designed and built a lot of robotic machinery in my earlier life before I got into the video conferencing business. And in this life, I'm the founder of Spranto, and we do software. And I've also authored a number of ITU recommendations, including the NAT Traversal, which I'll demonstrate here as well, which is the direct media technology. Now, what we're going to talk about is motorized conferencing. This is really my pet project. This is the thing I love to do because this is right up my alley. We're talking about motorized conferencing. When we took it to the ITU about robotics, we had to define what was robotics, what was video conferencing robotics. And part of the decision we decided was it was primarily a video conferencing device that can move or do some function in support of video conferencing. So these are two examples of next generation video conferencing devices. The one on the left is essentially a Segway that runs as a pole and has an iPad on the top of it. The one on the left here is the little device here I have here. This is a little neck device which can do pan tilt arrangements similar to what the fire-end camera control can do. So the robotic revolution is really coming about, and that's really come powerful with the iPad and tablets. With iPad and tablets, these devices can not only run a video conferencing service, they also support Bluetooth, which can then control any sort of robotics. So what we're seeing is a really increasing use of tablets and Bluetooth to drive machinery. So what we're seeing is the traditional design of having a hardware endpoint from a major vendor, having some sort of servo-controlled, big, expensive robots is now being changed to something much more smaller, modular, lightweight. So instead of having to buy a complete set unit, you buy just the base, and you buy the tablet separate. And so what you've seen is this, we're using off-the-shelf tablets, using Bluetooth control, soft clients, and the future is to use this new standard called H284, which is something we introduced in the ITU just this year. And the cost of these devices come down significantly. For instance, the one on the left, the entire operation is $2,500, I think, for the one on the left, and the one on the right is just $500. So the cost of these devices come down significantly. We were previously talking about tens of thousands of dollars for robots. They now come down to much more affordable prices. So what is FEMC, or far-end motorized control, and where is it at? It's currently a work item in the ITU in study group 16, question 1. It's called H.FEMC. We're actually holding industry and ad hoc groups to get industry involvement. We've got about 7 or 8 manufacturers, robot manufacturers involved in the standardization process. And it's being chaired by Mr. Patrick Luthi, who's very busy, busy doing that and rounding up people. And it works with 323 and 320 via 224, which is exactly the same as fire-end camera controls. And yes, it will also work with SIP. So what we're doing is something that could be universally supported across 323 as well as SIP. Now, what's the difference between 281, which is the fire-end camera control, the traditional fire-end room system control, and FEMC? The difference is H281 is a simple start-stop. So you put your finger down, camera, stop. And whereas 284 is much, much more rich than that. Yes, it has the same simple start-stop operations, but you can do things like absolute positioning. You can set up limits. For instance, on this little device here, you have 180 degrees left and right, 90 degrees up and down. You can set those limits. And you can set the absolute position within that limit. So you can tell this device to go to a specific position within those limits. And you can also do incremental positioning. So you can tell it to do a stepping motion. So you can say, like a stepping motor or something, where you can say, step 3 units in one direction, 2 units one direction. So you can have precise positioning. 281 is limited to a limited number of axes of control, which of course is your pan, tilt, zoom. That's about, and your presets. Whereas 284 has the ability to do 255 different axes of control. So you could have a robot that does forward and backward motion, left and right, pan, tilt, zoom, lights, any extension you want on top of that. So you have this full richness of possibilities that you can do with robotic control. What does it provide? As I said, it's 255 and 225 of simultaneous points of control. We call them control points. These can be linear, rotational, translational, simple on-off functions. They can be done, so they can be, again, like simple stop-start, absolute positioning. You can have a minimum, maximum, current position, and you can also support such thing as a viewport. So for instance, this little tablet device here can pan 180 degrees left and right. But at any one particular point, you only got a 35 degrees point of view. So you can specify that the current position is as one position, and you can specify the point of view. So what you can do is you can translate that into absolute positioning on a tablet. So what I can do is have it on my screen on my tablet, push a position, and I can get it to center on that position using a viewport. I'll demonstrate that when I get to it. So you can also do a number of incremental instructions, each increment of X number of units. Now this is what this is taken straight out of the working document. So we've got here the different control point numbers. So we have a 0 preset, so we can set everything go back to its original position. We could say, go back to its default position, 0. We've got movement forward and reverse, movement left and right, movement up and down. We've got neck tilt, pan, roll. We've got camera zoom, camera focus, camera lighting, auxiliary lighting. So it's just designed to provide, as well as a large number at the bottom for user-defined. So these can be used by any implementer to divide their own control point. So these are functional control point numbers. So what happens when you set up a call, what will happen is that your device will tell the receiver what it supports, what its limits are, what its current position is, and what its viewport is. So you can preset your tablet, provision your tablet to support whatever the mechanism needed to simulate robotic controls of that device. So what happens is we transfer every single control point mechanism into a equivalent linear positive scale. What that means is we specify a scale from 0 to some number. We will give it a current position. There's some arbitrary numbers. These aren't real. All we need to know is that we have a scale. So for instance, this is a 180 degree pan. We'll tell the device we go from 0 to 180. Its current position is 90. So these scale information is linear positive scales. It advertises how it wants to be controlled, whether it's start, stop, whether it's absolute or incremental. You can specify a minimum value, a maximum value in its current position. And again, a point of view, which is the viewport of what scale it has. And you can provision control points accordingly. And what happens is you take your tablet, and your tablet provisions itself to whatever the information provided from the far end are. So you could have slider scales, you can have you can click on the screen type arrangements. You can do whatever you need to do. The far end device notifies the caller of how it wants to be controlled. Now, I'll give you I sort of rushed through this, but I'll give you a demonstration of how this actually works. So I'll make a call from my tablet to this device. If you'll pick up, turn on the video. So what we have here is we have a tablet. This is positioned here. So I can tap anywhere on this screen and notify the camera to position in that particular location. So if I I'll set it down here. I'll focus on the little presentation window down here. I can then move it. And I could focus on people on the crowd. So I will focus the person far down the back, Mr. Luthi. He's now centered in the screen. Yes, there he is, waving away. But I can focus him on here. So I can actually focus on other people in the crowd. So what the camera can, well, it seems we have a packet loss issue. But I can tap anyone on the screen, and the device will position itself to wherever I told them. Mr. Kubo, you over here. You got Mr. Kubo. Position yourself on Mr. Kubo. Sorry? Is it come out, has it? Oh, okay. Oh, you can grab that. So the device doesn't come up. Okay. So in this particular way, we can also have a sliding scale. So I can position an absolute position. So I have a little scale down the bottom here. So what happens is when I set the call up, the device here has told my device that I have two axes of control. I have a pan and a tilt. And so I'll be able to provide two sliding scales. It also notifies them what the limits are. So for instance, this device has notified the limits of 0 and 180 in the horizontal, and 0 and 9, oops, sorry, I tapped. Give it to Mr. Kubo. That I've got plus and minus, I got 90 degrees in the north and the vertical. I've also positioned a viewport on the screen. So what happened is this device has notified them that we're currently positioned 90 degrees in the horizontal and 45 degrees in the vertical, for instance, and we've told them that there is a 35-degree angle of view. So this screen represents the aperture of that particular camera. So at that particular, if we're using that, I could tap anyone on the screen and get it to move to wherever I want it to go to. So I can tap it over here. There we go. And I can get it to focus. I can go up and have a look at the top there. Have a look at someone inside there. It's a little bit pixelated. But I have this full level of control of the robot, and I can hang that call up. So that's basically a simple example of how you can control how far-end motorized controls worked. Currently, the document is a work item, as I said. We'll be presenting it in 2 weeks with Mr. Patrick Luthi. Will be chairing our question, and we are currently soliciting interest. We're currently soliciting interest, and we really would like to get, as I said here, the contacts are myself or Patrick, and we will be doing some work at the Geneva meeting from the 28th to the 8th of October, and the latest information on the FEMC document is available at that linkage. But we're very interested in getting industry acceptance, not just from the robotics industry, but from the video conferencing industry as well, and get them to come together and see how we can exploit this great new involved technology. Thank you very much.